So we're going to go ahead and talk about how to use the power rule now, which remember is just a glorified version of the product rule I just showed you. So in this case, my r is square root of 3. So remember, you take the square root of 3 and you raise it to whatever the power is. So we just raise it to that same power. And then I'm going to do shorthand, so shorthanding it. And I'll do 15 multiplied by whatever the power is. So we will get, well, square root of 3 to the 4th is the same thing as 9. Cis 60 degrees. Now, we'd be done if they said just to keep it in polar form. But of course this problem is nasty and it says we want to go to standard form. So let's talk about how to convert this to standard form now, which really means we just need our x and our y. Now remember, x is r cosine and y is r sine of theta, which notice are right here. They actually show you that. They give you the answer right in the context. Because to find our x value, we just need to figure out what 9 cosine of theta is. And then to find our y value, we just need to find out what 9 sine of 60 degrees is. Okay, so it's going to be just some unit circle math. If the angle doesn't happen to be in your unit circle, you just use your calculator, you type it in. So 60 degrees though is a value that we have an exact answer on. So 60 degrees is about right here. So the cosine value will be a short side. So it's going to be the 1/2. And then the sine value is the long side because we're going up. So that's the square root of 3 over 2. So we've got 9 over 2 plus 9 square root of 3 over 2i, or however you want to write that. Okay? So let's go ahead and do another one just to get you feeling more comfortable about that. Once again, notice it says our final answer needs to be in standard form. So let's go ahead and use our power rule. So 2 to the 5th, I'm going to go ahead and raise it to the 5th power. And then I'm going to shorthand it. And I'm going to do 4 pi over 15. This time I'm multiplying by 5. Simplify that. So we get 32 cis. And then this simplifies down to 4 pi over 3. So we're going to go ahead, since it did say standard form, we have to keep going. Otherwise, we actually would have been totally done. So to go to standard form, we'll do 32 cosine of 4 pi, thirds, and then 32 sine of 4 pi thirds. There we go. So he's going to figure out each one of those. Once again, if this 4 pi thirds was not an exact value on the unit circle, you just type it into your calculator. But we're in luck. 4 pi thirds is right here, which tells us our x value should be the short side, and so it's going to be negative 1/2. And then our y value will be the long side, so once again it's the negative square root of 3 over 2. And then you simplify that, so we get negative 16 minus, since it'll end up being negative, minus 16i square root of 3. And there is our final solution. Let's do one more, only because this one's unique in that it's already in standard form. And because of that, you could actually go ahead and use Pascal's triangle, binomial theorem, or just simple foiling, distributing rules to figure out the solution to this by just distributing. If you really want to do that, that's totally fine. I'm going to show you a way to do it with the cosine though, or with the polar form though. So remember, in order to convert to polar, we need to find our r and our theta. 2 and 2 are our x and our y, because this is our imaginary axis. So I'm going right to and up to, so this is going to be an isosceles triangle. This should be familiar from what we did. So it's a 2 by 2 right there. Should feel familiar for what we did on the very first lesson. It actually tells us it's a 45-degree angle right here. And our radius should be 2 square root of 2. I don't know why I've made that so small, but you get the point. So this is 2 root 2. Oops. So our radius is 2 root 2. Our theta is 45. I don't mind if you do 45. Or you can do the radians. I don't really care one way or the other. I'm just going to do radians because it seems fun. I like a challenge. Okay, so we've got 2 root 2 cis pi fourths. All of that raised to the 3rd power. So now we can go ahead and raise things and use our rule. Oops. That should be a 2 to the 3rd power. And then pi fourths times 3. So notice we're using that 3rd power all the way through. 2 to the 3rd is 8. And then we've got square root of 2. So I did 2 to the 3rd. And then I'm also doing the square root of 2 to the 3rd. So this was 8. Square root of 2 to the 3rd is the same thing as square root of 2, square root of 2 to the square root of 2. So this portion, right? Well, square root of 2 times square root of 2 is 2. And then we've got a square root of 2. So we've got 8 times 2 square root of 2, or 16 square root of 2. This is 3 pi fourths. Well, here's the one unfortunate part. If you don't, like, I can understand why you wouldn't want to do this. But we do have to go back to standard form again. So we would have to find our x and our y value. So our x being the 16 root 2 cosine of 3 pi fourths. And then our y value being 16 root 2 times the sine of 3 pi fourths. If I were you, I'd start doing it in my head if I can. And just remember which one's cosine, which one's sine. You just need to remember we're in 3 pi fourths right here. And so we'll take 16 root 2 and multiply it by our negative square root of 2 over 2, since we're talking about the x value. And then the y value at 3 pi fourths is positive square root of 2 over 2, which if you simplify those will give you negative 16 plus a positive 16i. And that's your final answer.